Hello, today we are going to take a look at this green cell 2000 watt 12 volt true sine wave inverter, and I will try to power my dishwasher using this machine, and we are going to see if it's going to be working. And let's take a look what we've got inside. That 2000 watt on 12 volt, we need a beefy cables. They go with interesting route of using two sets of wires instead of one beefy. I will definitely replace them for something like this, and if you would be curious, this is a welding cable and you can buy it much cheaper than color-coded red and black. The only thing you need to do is color-code the endings as positive and negative, but you just add a heat shrink tube and you are good to go. Those are 45 amp, so I would expect all of them are being required because this is not enough for two sets. And let's take a look. How does it present? And here we've got our label with specification. And we've got rated power 2000 watt. I would assume this is a continuous rating. And we've got the peak power, the surge 4000 watt. And basically anyone who is using that value first to sell you something is dishonest, because the peak value, it is not like a minute for boiling water. It is like a milli or microseconds. You need to measure that on oscilloscope. And this is how it presents. We've got the aluminum chassis. We've got all our finals. We've got the 2000 watt. Absolutely beautiful. European Schuko plug with grounding. We've got a ground bonding terminal. Very good. We've got USB. This is a joke. On back we've got our DC input. We've got two fans. According to the box, they should adjust RPM based on temp. And let's take a look how to remove that protector. We remove it like this. Absolutely beautiful, and I will be using those. There is basically no way to put this protection while using those two supply wire, because you can stack them like this. As you can see, you cannot go like this because you will be bending them. So they need to be like this, little bit cross, so we've got a good connection. And if you do it like this, then you can't put it back. The hole is not enough. You see? You can go like this. But you will not lock it. Not a very good start. This don't look good. On final installation, of course, I will crimp a proper connector or on at least 35mm square wire. I've got my BMS, but I do not see any remote controlling port, so most likely you could not use it with that. We are attached to my Victron Energy lithium iron phosphate battery, so the voltage should be absolutely the most beautiful. We are going to turn it on. The green indicator, we do not have any fault. Let's try to measure idle current. So we go like this, and I'm clamping one wire, and we've got 320 milliamp, but we've got two wires. And in ideal world we should see exactly the same value. We are very close, so looks like the resistance of the wire and connection is great, because if there will be unbalance, then it would be scary on high current, but looks like it's okay. And let's try to apply some load. I grab my lamp that we always use for testing, and let me plug it in. It started nicely. Let's measure the current again, 1.4 amp, basically times 2. Let's try to plug in my dishwasher because that should be more interesting. I've got extension cord and that power stripe, and we are on. We clamp those two wires together and I will plug in the dishwasher. Dishwasher is plugged in. We are ready to power it on. We go from the battery and I will set the highest temp so the heater is going to be working. And let's see what's going to happen on the meter. Now only pump is working, and as you can see the current draw is extremely small. But we are waiting for the moment when the heating element is going to kick in. Looks like heating element kicks in and I've got overcurrent. Actually, we can be smart and we can measure just one wire, and we've got 55 amp times 2, 110 amp. Going from the Victron Energy battery. It's cold to touch. Wires are slightly warm. The terminals are okay, but we need to wait. I would like to see the fan kicks in. At this moment, I can hear the fan started. And looks like it's adjusting PWM. So thank you very much for watching. I hope you find that interesting. See you next time and bye bye.